This is a machine that's less than a year old. It's the M1 Ultra Mac Studio, a very expensive machine that I paid over $4,000 for. 64 gigs of RAM and lots of processing power. In this corner, we've got a much smaller machine. This is the base model M2 Mac Mini that costs $600. And I'm gonna kick things off right away with this Python program that I'm gonna run. I'm gonna run this with a time command so we see how long this takes. And I'm gonna give it a parameter of 5 million. And let's go. By the way, this code is on Benchmarks Game. I've used this quite often on the channel. I'll link to it down below in case you wanna run it yourself. And we've got, what? Wait a minute, that took 20 seconds to run on the Mac Mini and 27 seconds to run on the M1 Ultra? That has to be a mistake. Let's do that again. What's going on here? I'm actually gonna do the 50 million because I got the same score again. Huh, and here is the rub, as they say in England, I guess. All right, that joke's getting old, Alex. Here's the rub. Over here on the Mac Mini, we have the M2 chip, the SoC, the system on chip. And each individual core of the M2 is faster than each individual core on the M1 Ultra, even the M1 Ultra, yes. So if you're doing single core operations, then yeah, the M2 is gonna beat the M1 Ultra, even if it's in a tiny little package that costs a fraction of the price of this machine. You can see from the history, the CPU history, that we're only using 1 or 2 cores at most. In fact, this is a single core operation. So yeah, the green lines are there on core 5 and core 6. They're actually alternating. So it's jumping between the cores, but it's a single core operation. I'm gonna show you a multi-core test in a second and you'll see how that changes things a bit. Now, here's another test, Speedometer 2. It's a web browsing test. Now, I do have a video that I did recently on this. I'm just trying to prove a point here for just a second, bear with me. I would not use this particular test going forward as a real benchmark of performance. And I'll link to why in a video down below. But nonetheless, we get a higher score on the tiny little Mac Mini than the M1 Ultra Mac Studio. These are all single core tests. And when you're using the machine, everything is very smooth. Even on the M2 Mini, I haven't had any issues. As long as I only have 1 or 2 programs open at a time, I don't have any problems using them. Here I got Xcode open. It works fine. I can create a new project. There's zero lag in absolutely anything that you're using here. Let's create a new project here as well. Here we are. And I'm just gonna run this project. And the simulator popped up first on the M2 Mac Mini. And the app started on the Mac Mini by a long shot. We're still waiting on the Mac Studio. There we go. Now, that is not a typical behavior, but I thought I'd keep that in the video anyway, because really an Xcode project build is a multi-core build. This is a very simple app. I just wanted to demonstrate here that there is absolutely no lag in usability for a developer, as long as there is only 1 or 2 apps open. This machine only has 8 gigs of RAM. So eventually, if you have more stuff open, things are gonna need to go somewhere, and they're gonna go to the SSD because they're gonna get swapped out of memory. If we take a look at the memory load right now, we already have swap being used, almost a gigabyte of swap being used on the Mac Mini. It's so far not giving me any problems. Of course, over here, there's 0 swap being used, and we're really far away from using any swap at all. So we do have some memory pressure going on here, no problem at all. When does it begin to matter though? At which point do you have to say, well, maybe that's not gonna be enough for me for software development? Well, let me show you something. It really depends on your tolerance, what you're gonna be doing and how you're gonna be doing it. For example, sometimes even with really powerful machines, if we have a large enough project, we kick off the build, and as developers, we take a break, we go for a walk, we take a lunch break, we, I don't know, browse YouTube and watch YouTube videos. Nobody does that, right? And no matter how fast your system's gonna build a project, you might just take a couple minutes to do that out of your day. And this is normal, right? If that's the case, and that's how you work, I'm gonna say it also doesn't matter which machine you're gonna be using. But if you're gonna be sitting there staring at it, watching the kettle boil, as they say in England. They don't say that in England. Stop saying that, Alex. What the heck? Let me show you what happens then. I'm gonna show you 2 projects again, a Python project and an Xcode Xcode project. Here is a program called Mandelbrot, and you've seen me show this on this channel before. So it's also from Benchmark's game, but this one is this algorithm right here. Different algorithm, and this algorithm happens to use, well, it happens to use all the cores that are available. It's gonna really greedily munch them up. You'll see in a second. So if you wanna run this yourself, feel free to do that. Here we are. I'm gonna kick this off with a small version of this. Like, you know, if you have a small project. Let's go. Yeah, this thing beeps, by the way. I should have sent it to dev now. I'll do it with the next one. So here we've got 0.2 seconds total on the M1 Ultra Max Studio, 0.75 seconds. So on a small project, on a small scale, again, doesn't matter. But what if it was a larger project? 16,000. That's the parameter that they actually suggest using in the test. And I'm gonna actually send this to dev null so we don't hear that annoying beeping. Let's go. Now here, while this is running, let me show you something. If we take a look at the CPU now on both of these, you will see that we've got quite a bit more load going on. Look at that. I had to restart the one on the Max Studio because it finished already first. But I just wanted to run it again real quick to show you what's going on with that load. And you can see this is a multi-core test. And this Max Studio has 20 cores. 20 cores that can do the work in parallel. Whereas this one has only 8 cores. It also does them in parallel, but obviously there's a lot less going on there, a lot less work being done in a given amount of time. So what's the result? The result is 17.3 seconds on the Mac Studio, 46.5 seconds on the Mac Mini. This is where it really starts to matter. If you're gonna be sitting there watching your builds, you're gonna be watching them a lot longer on the Mac Mini than the Mac Studio. Let's have a look at one more test. Now you might say, who the heck cares about Mandelbrot and N-body Python benchmarks? Let's take a look at a more realistic example of an app. Well, that's why we have Xcode Benchmark. It is still called a benchmark, but it's a project that has a lot of CocoaPods in it, which is realistic. An app might have a lot of dependencies that you bring in, third-party dependencies that have to get built along with your app, and that's what this test represents. I'll link to this one down below. And just before it finishes, I'm gonna have it say Mac Studio terminated. This one's gonna say Mac Mini terminated once it's done. All right, let's go. Now this is using Xcode tools. Even though I'm not building it from Xcode, I'm using Xcode command line tools to do the build. So it is an Xcode test, it's using the Xcode utilities. And because it's an Xcode project, it's also utilizing all the cores. It's a multi-core test, so you know what's gonna happen, right? But by how much? How much is it gonna really affect your waiting time here? Well, that's what we're about to find out.
Mac Studio terminated.
Mac Studio terminated. That took 69.8 seconds. That's really good, waiting for this one. Still waiting.
Mac Mini terminated.
This one took 110 seconds to do. So it took almost 2 times longer for the Mac Mini to build than the Mac Studio. Build times will be affected if they are going to be multi-core builds. And a lot of tooling these days will be multi-core builds. They'll take advantage of all the available cores. Now, it doesn't mean that this is not a good machine for developers. When you're doing your builds, you're gonna have to walk away. You're gonna have to wait a little bit longer. And if you're okay with that, that's fine. Also, you might have to be careful about what you're using, because if you have multiple tabs open in your browser, well, here, let's do that. All right, so I've just popped open 15 tabs in Google Chrome. This should represent how I normally work and what I have open during a normal workday. I probably have more than like 30 tabs open usually, but we'll be a little conservative. 15 on each one of these. I've got Xcode open. I've got 2 instances of Visual Studio Code open. I've got a simulator open. I've got Notion, a nice note-taking app where I keep track of my stuff. I got a Todoist, which is, they're both Electron apps, by the way, so those are gonna be hoggy. You know what I'm talking about, right? By the way, just for a second, if you like this video, please hit that like button. I appreciate it. Thank you. It really helps out. And if you're not subscribed yet, you like this content, hit that subscribe button. It's free, and you'll see more of me. Not that you want to see more of me, but you might want to see more of what I'm showing you. That's good too, right? Anyway, let's have a look at Activity Monitor now. Ooh. You see this? Under memory for the Mac Mini, we're using 1.2 gigabytes of swap now. We're up right up there to the memory limit and past it, I would say. It says memory use 6.95. We only have 8 available on the machine, so we're using a lot of swap, and the pressure is in the yellow, which is kind of iffy. You don't want that to happen. This one, sitting nice and easy, 0 bytes of swap used. Now, if you want to open a program like Parallels so you can run Windows at the same time, forget about it. This machine will not be able to handle it. So if that's your workflow, I'm sorry to tell you, the Mac Mini is not gonna cut it. This Mac Mini is not gonna cut it. Some of the bigger models will. Now that we have all this stuff open, let's run one of our benchmarks again to see what the difference will be. I'm just gonna go to this Xcode benchmark again and run this same exact test one more time. Let's go. Well, they both finished, but I gotta say, this was a surprise to me. I'm impressed actually with the M2 Mac Mini. And here's why. This one took 70 seconds, which is actually a second slower than the last time I ran it. Fine. But this one, 110 seconds, which is pretty much the same exact time we got last time, even with all the stuff running and all the stuff open. So, like I said, this smoothness is still there. Like, there is no sacrifice of opening programs, usability, switching between tabs, navigating your project, navigating your code. Everything still works. Yes, we do have a ton of memory pressure. We do have some swap being used. And this, by the way, is the default 256 gigabyte drive in there that's supposed to be slow, right? If you haven't seen my video on how to improve the speed of that, check that out as well. I'll link to that down below. It's useful for certain scenarios, clearly not this one. So if this video was useful to you or entertaining or otherwise, I'd appreciate a thumbs up again. Thank you so much for watching, and I will see you in the next one.